Let's just pick off, I guess, where we left yesterday, linear equations and inequalities, right? Let's start with these questions. What does this say? This one says, for each set of equations, select the solution from a given set of numbers. So they're basically giving you the options for the solution. We don't really need the options, right? Because these are all very simple. Like for A, how do you solve this for S? It's a very simple linear equation.
You subtract 1 and divide by 4.5.
Easy as that, right? What about B? What's the first step? What's the second step? There's two things you can do for B on the first step.
Divide by 2.
Yeah, divide by 2, and then you can subtract 6.5, right?
Mm-hmm.
What about C? What would you do first?
Add 4.
Yeah, you have to add 4, so that's gonna be, what's negative 2 points? 1.5. And then you multiply that by 7, and you're done. What about D? What do you do? This one.
Could you open the bracket?
Yeah, if you open the bracket on the left, what do you get?
Negative 2r minus 1.
It's not gonna be minus 1, it's gonna be plus 1. Yeah, what about on the other side?
6 minus 4r.
Okay, now what? We're trying to solve this equation for r. What do we do next?
Subtract 1.
Subtract 1 works, yeah, so you get 5 minus 4r. What's next?
Add 4r.
Okay, so 2r plus 4r is 2r equals 5, and r is 5 over 2, and we are done, right?
Mm-hmm.
It's not that bad. I don't really care about that. Let's move on here. Let's try doing some tricky linear equations. Right here, what do we do first?
Add 1.
Okay, so you're gonna get 5n over 3. That is equals to 3n over 2 on the other side. 4 plus 1 is 5. All right. Now what? We're trying to solve this equation for n.
Multiply by 3.
That's kind of interesting. Yeah, it does work though. But just remember, if you multiply both sides by 3, you're gonna multiply this by 3. On the left side, you'll have 5n, because this 3 cancels out with this 3. What do you get on the right side?
9n over 6.
That's wrong. It's because you're multiplying it by 3 over 1. So for the first term, it'll simply be 9n over 2, not 6. Look at the difference here. 3 over 2 times 2 is 6 over 2. Whereas 3 over 2 squared is going to be 9 over 4. If it's squared, it applies to every element inside. Whereas if you're just simply multiplying by 2, what you're actually multiplying is 2 over 1. You multiply the numerator with the numerator, denominator with the denominator. Which is why 3n over 2 times 3 is just like saying 3 over 1. So 3n times 3 is 9n, 2 times 1 is 2. Okay.
Okay.
And then there's also the second term, 5 and 3, which is gonna be 15. All right, now what? The goal is to solve for n.
Subtract 9n over 2.
Yeah. So 5n minus 9n over 2 equals 15. What's next?
Multiply by 2.
For the 5n, or on both sides? Did you want to
Both sides.
multiply both sides? Okay, well, we can do that. But then just remember, when you do this, it's gonna look like this. When you open this bracket, what do you get? On the other side, you'll get a 30. What about on the left side? You're gonna get two
10n
things. Yeah, 10n. What about the other one?
minus 18n over 2.
Yeah, minus 18n over 2, which is simply 9n, because 18 over 2 is a 9. So like that, and 10n minus 9n, they're like terms, it's just n equals 30, and you're done. Okay? A little tricky with fractions. I want to show you another way to do this, which is what I would do. This is right as well, like, because we have fractions. Nobody likes fractions. What we're gonna do is we're gonna multiply both sides by something that'll help us cancel out the fractions. And it's going to be a 6 because 3 goes into 6, 2 also goes into 6 like that, okay? Now look at this, 6 times 5 is 30, 30 over 3 is 15n minus 6. On the other side we have 3 times 6 is 18n over 2, 9n, and then 4 times 6 is 24, like that. Then we can move this to this side, I can move this to this side, okay? So you'll get 6n equals 30, and n is gonna be 5. Cool? It's a little bit easy if you can multiply, if you can kill the fraction to start off with, it'll make your life a little bit easier, which is what you should probably do for f. Like you can play around with it if you want, which is also right, but the most efficient thing to do would be right off the bat, if we could multiply both sides by a number that completely kills off the fractions. What do we multiply by? Think of a number that, well, the number is always going to be the LCD. What's the LCD between 2, 3, and 4? The lowest common denominator between 2, 3, and 4. 12, yeah, exactly. So multiply both sides by 12 to start off with, okay? And you can do this. You can do anything as long as you do on both sides. And now let's open this bracket. 12 times 1 is 12. 12 over 3 is 4. So 4x for the first term. What's the second term on the left side?
It's 6.
Yeah. So you can also think of it this way. 4 goes into 12 3 times, right? Like that. So 3 over 4 times 12, or in other words, 36 over 4 is 9x minus 12 over 3 is a 4. And there we go. We've completely killed off the fractions, and it makes things so much easier. Add 4 on both sides, you'll get a 10. Subtract 4x from both sides, you'll get 5x. So therefore x is 2, final answer. Okay? So this is a neat little trick. Like basically killing off all the fractions. This one's pretty simple. You just open the brackets and put the like terms on both sides. Let's look at a word problem. Phone company charges $12.50 per month plus 0.15 per minute. Write an equation to determine how long a person would have to talk to be charged $23.90. So I think this is a monthly cost, okay? This is your monthly cost, the monthly bill or whatever. What could be an equation that represents this situation? It's going to be a linear equation for the monthly bill. Let's say the monthly bill is given by y, okay? And x represents what? Well, it would represent the number of minutes. So what could be an equation here in this case?
12.5x plus 0.15.
So 12.5 is going to be your y-intercept because in a month you only pay this once. This is your flat fee monthly, right?
Oh, okay.
This you have to pay no matter what. The bill will depend on the number of minutes that you talk. So that there you go. That's the answer to A. Part B, solve the equation. Well, we know why the bill is 2390, right? Equals 1250 plus 0.15x, like that. How do we solve this for x?
Subtract 12.5.
And then,
Divide by 0.15.
yeah, that's it. Pretty simple from there. 12.5 divided by 0.15, you get 76. So x is 76. So if you talk for 76, you'll get that bill. Part C says verify your solution. Verify just means plug it back in and see if it works. So we're going to plug it back up here. So y is going to be 1250 plus 0.15 times 76, and that gives me 23.9. So there you go. That's right, because that's the number that we started off with, okay? So this is a way to double check your answers as well. What is going on here? Well, again, the number line question is very simple. Like, for example, the first one, I see it's going left. Its starting point is 2. It's inclusive. So you can say x is less than equal to 2, right?
Mm-hmm.
What will be the answer to B? Look at the arrow. Arrow is going right.
3.5.
Yeah, that's it. X is greater than 3.5. These questions are super simple. What about this? We know it's going to be something is less than, right? Because it's going left. And it's going to be just less than, not less than equal to, because it's not inclusive. It's an open circle. What is that number? Is it 1.5?
No.
Look at this. It takes 3 boxes for 1 unit. 3 boxes is 1, right? Because from here to here, the distance is 1. If 3 boxes is 1, how much is each box? Divide both sides by 3.
So it's 3.3.
1/3, right? Okay, so each box is 1/3. So that means this one is 1 and 1/3. This one is 1 and 2/3, or 1.666. Like this is gonna be 1.33, 1.66, and then finally you get 2. So that number there is 5/3, or 1.66 recurring.
Okay.
Make sense?
Mm-hmm.
What about D? What's that number? That's right between 2, and that one's easy because it's right in the dead center. Like this number here.
It's
Uh,
negative 2.5.
yeah, and we're going greater than, so it's going to be x is greater than or equal to negative 2.5. This one's interesting. It says, solve each inequality and graph the solution. All right, cool. For A, how do we solve this inequality?
You add 5.
You add 5.
Oh, you subtract.
Right, so you get negative y is greater than 2 minus 5, negative 3. What now? How do we solve this for y? Because right now we have negative y. No?
Do you multiply it by -1?
That's exactly what you do. You multiply both sides by -1. So x, y, and 3, and the fact that we're multiplying by a negative number, the sign in the middle flips. Okay? So let's say this is 0, 1, 2, 3. You can call this y. So less than 3, open circle, and then we go left. And there we go. That's the answer to that one. Cool? Easy, easy. B, you just multiply both sides by 2.4 and you're done. What about C? What's the game plan for C?
Subtract 2.5.
Yeah, that's gonna work. So it's gonna be 2.7x. Negative 2.4 minus 2.5 is negative 4.9. Now what?
Add 2.7x.
Add 2.7x on both sides? How does that help? That doesn't help us.
Subtract.
Subtract, yeah. So 1.3 minus 2.7 is negative 1.4x, and this is less than negative 4.9. Now what?
Divide.
Yeah, divide both sides by negative 1.4. And then the sign in the middle will flip because we're dividing by a negative number, right? 1.4, and I get 3.5. So x is greater than 3.5. So how do we graph this? Well, just to say this is 0. And now, because we have a 0.5 element there, what we do is we're going to say 2 boxes is 1 unit. So this is going to be 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. And we're going greater than, so we get this, and that's going to be the answer to this problem. Cool? It's pretty simple. D is also kind of simple. You divide both sides by negative 3, so you'll get, the sign is going to flip. Now what? We're trying to solve this for D.
Subtract 2.
Yeah, subtract 2, so negative D is greater than or equal to negative 4. What's the last step?
Multiply by -1.
Yes, so D is going to be less than or equals to positive 4. You can say this is 0, you can say this is 4. So less than, equal to means a closed circle, and then we go to the right, to the left, and we are 1 and done. Number 7, a word problem. So this person wants to go to a fair. The admission costs $4.50. So this, you're gonna have to pay no matter what, right? This is the flat fee that you have to pay. That's gonna be your y-intercept. And then per ride, it costs $125. She has 25. In fact, it says spend no more than $25. How many rides can she go on? So what will be an equation for this situation?
Um, 25 equals 1.25x plus 4.5.
All right, it's just 25 here. So now look at the wording. It says spend no more than 25, right? So what that means is that it's not an equation, it's an inequality. Okay?
So less than and equals to.
Yeah, less than equals to. Could be 25, but could also be 24. If you're saying equals to, that means Christina is gonna spend the whole of $25 for sure, right? But that's not the case, no more. All right, how do you solve this for x?
Subtract 4.5.
Yeah,
And then divide by 1.25.
right, so 25 minus 4.5 divided by 1.25, you get x is a weird number. X is less than equal to 16.4. Using this answer, what's the answer to part B?
She can go on 16 rides.
She can at most 16. Okay. So the max number is that she could possibly go on is 16. Verify the solution just means you just put this answer back into your main equation and see if it works out. 1.25 times 16.4 plus 4.5, voila, it's 25, so it's verified. Not that tricky. Okay, let's look at something else. I mean, these are pretty similar to what we're doing. Most of them seem pretty simple as well. Okay, so now we're gonna start doing something that we haven't really quite done. I kind of showed you a glimpse of this yesterday. I'm gonna graph an inequality. So far, everything we've seen has been like one-dimensional, like x is greater than 3 or like y is greater than 4 or something. But now we're gonna have two different variables on the same equation. So that means a number line is not gonna work. You're gonna have to graph this out, okay? How do you graph this out? How do you graph? Let's pretend it's an equals to sign in the middle. And I've asked you to graph this. What would you do? It's a linear equation, right? How do you graph a linear equation?
You start at the intercept.
Okay, what's the intercept? Is it in the right form for us to see the intercept? No, it's not. So let's put this in the right form. What do we do on both sides? If you want it in the form of y equals mx plus b. No?
You subtract 3x.
Yeah, you subtract 3x and then you're gonna divide by 3 as well. Right? And when you divide by 3, divide them individually. So you get negative 1x for the slope and the y-intercept is a 4. Like that. So let's start on the y-intercept. So 1, 2, 3, 4. What does the slope of minus 1 do? What's the next point here?
You go across by 1 and then down by 1.
Yeah, right there. And then you simply connect the dots. That's it, right? Graphing a linear equation is pretty straightforward. Do that, and then you can extend it on the other side as well. And there you go. That's the graph of that. But now we're graphing an inequality, okay? So that means you're gonna have to shade. And there's two ways to go about this. Well, there's two possibilities. Either we're looking at this part, right? Or we're looking at this part. What do you think? In which direction are we headed?
The inner part.
Down? So I mean down this one? Okay, so there is a way to deduce mathematically which side is good one. In this equation, just put a test point. Okay? So I'm gonna say, let's say x is something, I don't know, like 3 or something. Cool? So negative 1 times 3 plus 4, that's gonna be 1, right? So it's bigger than 1. Our y is gonna be bigger than 1. You can also put like way bigger numbers in there, like negative 1 times 10 plus 4, that's gonna be 6, right? So the fact that y is bigger than means we need to go above 1 or above negative 6. Okay? So that means we're looking at 2, 3, 4, 5, 6, because y is greater than 1. If we had if we were trying to do less than, then we would be looking at numbers that are less than 1. So the 1 is right here, yeah?
Mm-hmm.
So we're gonna go this way because we're looking at numbers that are bigger than 1, because y is bigger than 1.
Okay.
Like here they say something like, how do they word it? Yeah, it's test point. That's called a test point, okay? So in this equation, like if we were to go back, where is 0, 0? 0, 0 is right there. When x is 0, the y value is 4, yeah?
Mm-hmm.
Is y greater than 0 or less than 0? Y is greater than 0,
Greater.
so that means we're gonna go this way, okay?
Okay.
Let's try doing a less than problem. Okay, this one is it in the right form?
Yes.
Yes, it is. Our y-intercept is -1, and our slope is 4/5. What does that mean? Where's gonna be the next point? Where do we go from here?
Across by 4, down by 5.
Uh,
And
up, yeah, it's up. So 1, 2, 3, 4, up by 4 and across by 5. We're gonna end up there, okay?
mm-hmm.
So this is where we ended up on. Cool?
Mm-hmm.
Now again, the question, is it gonna be above or below? Like, are we gonna go down here or are we gonna go up there? What do you think? Use a test point, any point. It says y is less than, okay? Y is less than. Let's look at this point. What's that point? What are the coordinates of that?
5, 1.
5, 1. If we plug x as 5 in here, what do we get?
You get 4x.
No, x is 5, so 4/5 times 5 minus 1, yeah? 5 and 5 cancels out, you'd get a 3. Okay,
Oh, okay.
so does that tell you which way to go, up or down? I mean, the answer is right here. It says less than. Usually when it's less than, then you're always going to be going down, okay?
Mm-hmm.
Because over here, the y value is like pretty high, but down here, the y value is pretty low. How else can you think of this? So this is our graph, okay? Maybe if you don't want to use the test point approach, this is our y, right? So we want y to be less than. Less than means below. You can think of it that way. So this is going to be our graph. Okay?
Okay.
So the same idea as linear, except you just like pick something. Okay, here's a question for you. Let's say this is our equation. Let's say 4x minus 6 looks like this. Where do we go, up or down for this? Y is greater than 4x minus 6. Let's assume that is 4x minus 6. Are we gonna go up or down from there? Well, greater than means you gotta go up. So you'll be going this way. Cool?
Mm-hmm.
Greater than means you are gonna go this way. Make sense or no?
I guess.
Oh, let's see if there's more. Let's do one that's gonna trip you, hopefully. y is greater than equals to -1 plus x. Is it in the right form?
Yes.
So you're going to start at +1 and the slope is -1. So for every 1 unit you go across, you go 1 unit down. And now this is going to be your graph, right? Okay, question for you. Do we go up here or do we go down there? There's only one right answer here.
Go up.
Okay, why? What's the logic?
What exactly does the shaded area mean?
Uh, it basically represents what y can be. What y can possibly be. Like this equation, what does this equation mean? It means it gives you a relationship between x and y. If you change this into a greater than sign, this means y will strictly be numbers that are greater than the line itself. So think about it. Look at the y value here, okay? Doesn't matter what the y value is, just look at this point. The y value of this point, is it less than or greater than the y value of the line itself?
Greater.
Greater than, right? And we need it to be greater than, so we must be going this way. Okay?
Mm-hmm.
You can pick any point, like look at this point. Is the y value of this greater than or less than this? Well, it's less than, but we need it to be greater than, so that's why we go in this direction, not in the opposite. Okay, this one, it's in the right form. So -5 is somewhere here, and then the slope is 7. So that means you go up 7 units, gonna end up at 2, and then you go 3 units across right there. So your graph is gonna look something like this. Now again, a question. We need y to be less than, okay? Look at the y value here. The y value here is 4, right? Up here, anywhere, the y value there is 4. Now, is that less than the line itself?
Yes.
No, it's not. It's greater than, because on the line, the y value there, when you compare it, the y value here is just a 2. 4 is bigger than 2, right? But we need it to be less than. We go downwards, not up in this case. We will go here. You can think of it this way as well. The y value here, is this less than or greater than the y value of the line?
It's less.
It's less than. That's why we're heading in this direction, because we need it to be less. Okay?
Okay.
You understand the logic?
Mm-hmm.
It's pretty simple once you start seeing it, right? Yeah, there we go. This is the question that we just did. Now what if, okay, this one is doomed. Okay, here, questions for you. You don't have the equation, but could you decipher from the graphs if this is less than or greater than question? Let's look at this guy. The y value here, is this less than or greater than the line? The y value of the line. The x value is going to stay the same, right? Compare the y value here with its counterpart on the line. So is this less than or greater than that line?
It's less.
It's less than, right? So this must be a less than question, and it's not less than inclusive because it is what it is. For the next question, we're going to come up with the inequality. Hopefully we can. I think we can. All right, first, let's decipher what the equation of this line is. Do you see anything? Y-intercept the slope. What do you see? how do you go about finding the equation given a graph?
The y-intercept is -5.
Yeah? How do you find the slope? What's the slope? I mean, you can just count the boxes here. You go 1, 2, 3, 4, 5, 6 units up, yeah?
Mm-hmm.
And then 1, 2, 2 units across. So y equals 6 over 2, which is 3x minus 5. Okay?
Mm-hmm.
That's the equation. Now a question for you, because this is not an inequality. Sorry, this is not an equation, it's an inequality. Is this gonna be greater than, equal to, less than, equal to, greater than, or less than? What symbol goes in there? Only one of them is right.
Less than and equals to.
Yeah, less than equal. So let's check y is less than equals to 3x minus 5. This is the question that they had, but it's not in the right form, right? So if you were to put this in the right form, you would first subtract 3x. So you get negative 3x plus 5. And then you'd multiply both sides by -1. So y is less than equals to positive 3x minus 5. And there you go. That's what we have. So this is right. Okay?
Mm-hmm.
Makes sense? Less than, greater than. It's not that bad. And we know for 10 it was a less than question. All right, let's find the inequality of this graph. Do we know the y-intercept? Yes, you do. Okay, let's make this more difficult. Let's say we didn't know this. You can't use the y-intercept, because sometimes maybe you will not be given it. How do you find the equation of the line when you don't know its y-intercept, but you do know its graph, which is given here? You can't use the y-intercept. You're gonna need to use two different points. Okay, let's identify 2 points. Well, this point is 2 comma 2. Yeah. What is this point?
4, 3.
4, 3, right? Do you see what the slope is here? Slope should be pretty obvious. What's the slope of this graph?
1/2.
Yeah, 1 over 2. So we know our equation is 1 over 2x plus b. And the question is, how do you find b? Well, you simply plug in a point. I'm going to plug in 2 and 2. So when the y value is 2, the x value is also 2, like that. So this and this cancels out. So 1 plus b is 2. B is 1. The y-intercept is 1. But we know it was 1, right? But let's say they didn't give you this. That's why. So if you can just plug in a point once you know the slope. So therefore the equation is 1 over 2x plus 1. That's the equation. What about the inequality? Is it less than, greater than, less than, equal to, greater than, equal to? Only one of them is right.
It's greater than and equals to.
That's absolutely right, because this point up here, if you compare it to the line, it's more, so it must be y is greater than equals to. Cool.
Mm-hmm.
Which one did we just do? This one, right? Yeah, y equals, there you go. It's easy as that, okay? Any
Okay.
issues with this?
Nope.
Should be acing this on the test, ideally, I guess. Let's see if I can pull something else up. Let's start from the bottom, actually. notice in these questions, there is uno variable. There's only one variable, right? So that means this is a number line question. Let's say they didn't even give you the number line here. This is gonna be a number line question. Actually, that's not technically true. There's multiple ways to do this. Well, there's two ways. This is multiple. Let's say you have x is greater than or equals to 2. Well, on a number line, it's just gonna be at 2. It's gonna be an open circle, sorry, a closed circle, and it goes to the right. But there's also a graphical way of doing this, like a graph. What does the graph of x equals 2 look like?
Do you just draw a point at 2?
Just a point at 2 there, that's x equals 2. X equals 2 is a vertical line that goes through 2. See this? This red line is x equals 2. Similarly, you can have y equals 2, but that one's gonna be a horizontal line through 2. So let's say this is the x-axis. This is the equation of y equals 2. Okay? It's gonna be a vertical line or a horizontal line. But now we're trying to graph x is greater than or equals to 2. So again, instead of looking for the y values now, we're going to look for the x values for the test point. Look at this point here, random point, doesn't matter. Is the x value there greater than or less than 2?
It's greater.
It's greater than, so we must be going this way. Similarly, you can have like y is less than 2. So you want to draw a dotted line at 2 because it's not inclusive. Dotted line means it's not equal to. And then you want to pick a test point like here. Is the y value here less than? Well, yes, it is less than, so we're going this way. Did you notice the distinction, the difference? So just remember, x equals 2 on a xy plane looks like this. A vertical line, x is vertical. Or you just draw a line that goes through 2 on the x-axis. Okay. How do you solve this linear equation? We want to solve for x. Say that again.
Subtract 4.
Okay, so -7, 4 minus x is equal or greater than or equal to -22 plus 7x. What's next?
Could you divide by -7?
No, you wouldn't. Because 22, 7 doesn't go into 22. That's primarily why. You could though, won't be wrong, but there's a better way. Here you would open the brackets, okay? Like dividing by 7 is not wrong, okay? But there's a better thing to do here, which is open the bracket. If you open this bracket, what do you get on the left side?
-28 minus -7x.
Yeah, or in other words, -7 times -x is positive 7x. -22 plus 7x. Now what?
Add -28.
This question is busted. Because now when you subtract 7x from both sides, you'll get 0x is 6, which doesn't make much sense. Can I answer this? 11. No solution. Yeah, there we go. Because 0x being 6 doesn't make sense, right? Because now look at this. Why doesn't this make sense? Because now when you go to solve for x, you're going to divide both sides by a 0. And what is that? Well, no one knows what that is. It's not possible in the math that we do. So all that work for nothing, I guess. But that could be like a trick question on the test. Let's try a word problem. So this person wants to become a member at a gym or whatever. The membership costs $135. Now again, this one should tell you that this is a flat fee. That's going to be your y-intercept. Members pay $2 to rent out the basketball courts. Non-members can rent the court but have to pay $11 each time. How many times would Tom need to rent the court in order for it to be cheaper than a non-member? So we need to come up with an inequality. It's just going to use all those three numbers. Any ideas?
What do you do with the 2?
Okay, so let's say Y is the bill, okay?
Mm-hmm.
If you're a member, then your total bill is gonna be, well, you're gonna pay that 135 regardless, that's your y-intercept, but then you pay $2 for each time you use the court, where X represents the number of times you rent the court, okay? So if you're a member, this is the equation that will give you the price, whereas if you're a non-member, you don't have to worry about the initial fee. 135 is out, but every time you use it, you pay $11. So that's the equation for non-member. So what does this say? How many times would Tom need to rent out the court? So 135 plus 2x, yeah?
Mm-hmm.
Would it be less than or greater than 11x? Well, we basically want to see when this one starts winning. Like we've done questions like this. Graphically, this means one of them has a high y-intercept and but it has a lower slope, whereas the other one has a low, well, in fact, the y-intercept is 0, but it has a higher slope, right? So
Uh-huh.
this is the member, this is the non-member. So we're trying to find when member wins, okay? So it's going to be greater than.
Okay.
So we want to find when members start winning, I guess. Or would it be greater than or would it be less than actually?
Wouldn't it be less than?
Yeah, it would be less than. If you look at the graph, it should be less than. And there we go. And then you can solve this, subtract both sides by 2x, so you get 9x. And does 9 go into 135? I think it does. 1, 45, 19. Sorry, 15. 15. So x is going to be less than 15. Cool?
Mm-hmm.
Okay, yeah, this is it's gonna be greater than because we're just trying to solve for x though. I know we're looking at the y is gonna be less, okay? But look at the variable that we're solving for. We're solving for x. So this means this should be greater than. So x is gonna be greater than 15. So at 15, their prices are the same, but more than 15 rentals, the member price ends up becoming cheaper. If we say x is less than 15, that means less than 15, the members, no, that's not it, right? When x is greater than 15, the member becomes cheaper. Cool?
Mm-hmm.
It's a little tricky, this one, but we have done this just without the inequality bit. Okay, this is a wrestler who's trying to make weight. This is also pretty, I don't know how to even begin talking about this. So basically what happens is that wrestlers or whatever, like these athletes, there's something called weight class, okay? Like it would not make sense if you're a tiny dude is trying to wrestle like this enormous dude, right? That's not fair. That would make no sense. This is not WWE or something, which happens by the way in that, and the tiny dude wins sometimes in that, but that's not real. In here though, there's something called weight class. So it's something like 125. There's like a 10-pound increase each time. These are pounds, okay?
Mhm.
165, 175, yada yada, 265, yada yada. So this is the weight. So there's something called weigh-in. So when you're contracted to wrestle or something, there's something called a weigh-in, and this usually happens the day before the fight or the wrestling match or whatever, the day before the event, okay? Even in boxing, everything, same idea applies. So what they do is when come fight day in the ring itself, they're not 135 pounds. Let's say this dude is 135. On the weigh-in day, he's gonna be 135, but on the fight day, he would have bubbled up to maybe all the way to 155.
Mhm.
So how does this happen? Where did the 20 pounds go? There's something called weight cut. Okay, weight cut. So in weight cut, what happens is this is gonna sound very grim. What they do is there's multiple ways to do this, but they literally sweat out a lot of the water in their body. This guy sweats out 20 pounds.
So that's just water weight.
That's literally just water weight. Yep. And how do you
Is that
lose?
healthy?
That is not even close to being healthy. People have died doing this.
But people still do it.
People still do it. Yep. It's because this gives you like a 20-pound advantage come the wrestling match day, right? So it's because of this they want like that competitive edge. They do it. Now, how do they lose so much water weight? Um, well, this starts months in advance, actually. Well, in the months, they don't lose water weight. They just try and lose their own weight, try and lose their fat. But during the week of the event, what they do is they drink very little water. They drink very little water. Two, they sit in saunas for hours. Is that healthy? Probably not. And they also like bike, and bike is pretty famous, like as in like the exercise bike that's like still they do this for hours as well. There's way more. They also wear like very thick like winter clothing, even if it's in the middle of summer,
Sounds ridiculous.
so that they sweat it out. So they do all these things to make that weight, and then after they step on the scale, after their weight has been officially recorded, they drink a lot of water and basically go like all in. Like they eat a lot, they drink a lot of water because they're gonna have to bubble up. It is extremely unhealthy. It's
Would
not,
the advantage really be helpful?
yeah, it would
Like,
be because 20 pounds is a big deal. That's almost 1/6 of your body weight. But the funny thing is, this guy is doing it, but his competitor is also doing the same thing. So why don't you just agree to fight at 135, right?
mhm.
Just stop the water cut, just do normal, just weigh in normally. But yeah, it's because this guy may cut more than 20 pounds. Actually, when you go a higher weight classes, people cut like 30 pounds, maybe even 40 pounds. Because a 40 pounds to a 135 is a lot, but 40 pounds to someone that weighs 320 may not be a lot, right? So they can cut 40. It is
Is this
weird.
like legal? Like,
Yeah, it is
there's a
legal.
reason.
Yeah, it is legal. I don't know why it's legal, but it is because they're
And
doing
what's
it
the
to
point of
themselves.
even like checking the weight?
Um, because of contract, because they're scheduled to fight at a certain weight class or weight limit. Yeah, that is what it is. Yeah, even 10 pounds make a big difference. So basically you're trying to outcut the other guy, your opponent, so you get a competitive advantage. Okay. Anyways, here, your Y value is gonna be your weight. What are they asking us? How many weeks? So your X value is gonna be your weeks, okay? So your equation is gonna be Y equals, and he's starting at 200 pounds, so this is gonna be your Y-intercept, the initial value, and then he's cutting weight, so minus 2x.
Okay.
Now in terms of inequality, this is gonna be negative 2x plus 200, and he needs to be less than 175, right? And there you go, like that. That's gonna
Mm-hmm.
be your inequality. How do you solve this for x?
Subtract 200.
Yeah, so it's gonna be 25 negative 2x, divide both sides by negative 2. Make sure to flip the inequality. So you
Mm-hmm.
will get this is negative 25, so you'll get x is greater than 12.5. Okay,
Okay.
that's it. So it'll take him at least 12 weeks or 12 and a half weeks to get to that weight limit. That makes sense?
Yeah.
Even like women, like athletes, they also do this. It's not just men that do this. It is whack. If you see a picture of someone cutting weight, it is quite disturbing because their whole body is like super like dehydrated, right?
Mm-hmm.
Super dehydrated. Hey, let me see if I can show you some pictures. Okay, yeah. If you just Google weight cut, if you look at this guy, does that look healthy to you?
No.
This guy's almost dying. Look at this guy. Like they have no water in their bodies is what it is, right? That looks this looks even scary. Yeah, anyways, let's call it a day there for today.
All right. Thank you.
See ya.